Hello everyone, this is Kalyan. Today we are going to discuss about the fourth experiment of digital signal processing lab. Here we are given 75 samples at a frequency of 25 Hz. So here we have taken the 75 samples in X and we have initialized some variables which we are going to use in this experiment in this code. So in this while setup we have to begin the code and then the while loop. We are going to put our main code in this to run repeatedly. So first we have applied the moving average filter to the given input signal X. So I have initialized the seven initial values of the moving average filter because so that we don't get any disturbance in the output, and then we are going to apply the moving average filter in here. Here we are going to applying moving average filter with L is equal to 8. Then we are going to apply the DFT, discrete Fourier transform, for the given signal. So we have in this, for int is equal to I equal to 0, I less than 75 plus plus. First I'm initializing both the real and imaginary values to be 0, and then I'm going to run a loop for the output of real and imaginary of I. So real of I is equal to, from discrete Fourier transform function we are going to tell that real of I is equal to real of I plus x of j into cos of 2 pi ij by 75. So basically we have applied the discrete Fourier transform coefficients, and then we are dividing it the output into real and imaginary part. Now finding out the magnitude of the function, output function, we get for magnitude of k is equal to square root of square root of real square plus imaginary square. This is how it is written. Then we're going to find out the maximum value. There will be two peaks in the output curve which we are going to see in further. So we need to find one maximum is enough because it is symmetric with the middle axis. So I am taking only first 40 samples for finding out the maximum value, and I am showing that maximum value index of that maximum value in k max. Now I'm going to find out frequency is equal to k max into 25 frequency by 75 samples. So the pulse rate will be equal to f into 60. So first let us see the output. I'm going to skip the part of the uploading part. So uploading is done. Now let us go check the output. Serial plotter. So this is how the output will be. See, this blue signal is the input signal, and this one is the discretized for and this one is the signal for which discrete Fourier transform is applied. So we are getting two peaks. So it is symmetric with this point. So now let's find out the pulse rate. We're going to upload the code. I'm going to skip this part again. Done with the uploading. Now let's go check the pulse rate. So we are getting the pulse rate as 120 Hz. That's it. Now let's go check with the autocorrelation function. I'm going to we already applied the autocorrelation function in the previous one. So I'm just going to run this. I'm skipping the part of explaining it. Let's uncomment this DFT. Comment. Now let's check with the autocorrelation function. So I'm going to go fast. We have taken the mean, remove the mean. We have taken the mean and we have removed the mean, and then we are going to find out the autocorrelation function. Then we need to find out the highest point. So from there we are going to find out the pulse rate using this. So let's check it. Let's check the output. So I'm uploading it. I'm skipping this part. Now let's compare the code with the autocorrelation function. So here it is. So the both we are getting both the same values. So this is how we relate. That's it. Thank you. I hope you like the video. Thank you.